So far, you learned about the basic syntax and also semantics or meaning for the if statements. Before we see many more examples about how you can manipulate the either single if statements or multiple if statements, I would like to talk about one more thing, which is about logical operators or logical operations. Let's go over that and just make sure, at least for this week, you are able to write some simple programs using selections or conditionals. But next week, we're going to talk about more advanced usages for the if statement, especially nested if statement. But now, let's do one thing at a time, as usual. Okay, logical operators. So logical operators are used to create compound Boolean expressions. So you can think about whenever we talk about compound, it's simply synonymous with complicated or more complex Boolean expressions. So the simple Boolean expression will be either true or false. So you can sometimes write true or false in your program. So these are simply Boolean literals, right? When we talk about Boolean data types, we talk about them. And slightly more complicated would be, you can say x larger than or equal to 5. So that's a Boolean expression, right? It's a simple one. It's just simply a relational operation. But now, in this part of the lecture, we'll talk about something that's slightly more complicated than simply a single relational operation. So now, analogy, similar to arithmetic operators for creating compound number expression, we want to use logical operators to really create compound Boolean expression, right? So you can think about, in some way, the arithmetic operator is a little bit like a Boolean, like a logical operators. We want to create complex expressions of Boolean type, which will evaluate to either true or false. That's the principle you want to keep in mind. All right, so now logical operators can combine Boolean expressions. Notice that they can combine. So you can think about logical operator. Remember, we talked about each operator should be associated with either one or two operands. So we are saying that each operand for a logical operator is simply a Boolean expression that can be they are built using relational operators. So let me show you an example. You can see this is something new to you. Okay. First of all, you can see this expression here in isolation. So this is a relational expression. Simply say x is larger than or equal to 1. And this is just another relational expression in isolation. So x is less than or equal to 10. You can think about this can evaluate to either true or false. And this can also evaluate to true or false. That is, this is a Boolean expression. This is another Boolean expression. And now we're using a new operator, so-called a logical operator. I'll explain what ampersand really means in just a moment. So this is one of the logical operators which we can combine Boolean expression with another Boolean expression. A little bit more precisely, you can see this operator over here without even knowing what it means. Is it a unary operator or binary operator? Well, it should be binary, right? Because you can see you got 1 and 2 operands, right? I'm just trying to analyze the syntax together with you before we talk about its meaning, which we'll do for sure. All right, number 2, you can see this is just another logical operation. We're just using another logical operator. You can think about this as one operator for logical operation. This is just another operator. And both of them are binary logical operator, both of them. And then you can see this is just the left operand for this particular logical operator. So the left operand over here is another relational expression which returns Boolean, which evaluates to Boolean. And this is just another one. All right. So hopefully so far you're okay with the syntax, right? You just got to make sure when you write the expressions, you want to have in mind what's going to be the type that's going to evaluate into. All right, so now we'll consider 3 logical operators for this course. Actually, in Java, you only have 3 logical operators, right? And for those of you who might be taking a larger course concurrently, so for example, 1019, you might have heard about logical operator, but if you haven't, if you're not taking this course, that's okay. So you can learn from scratch still in this course. All right, so now I'm going to show you a table quickly before I talk about the meaning for each operator. We're going to define that precisely. So I'm going to show you 3 columns over here. In this column over here, you're going to see the syntax for the Java, right? Exactly how you write it. And then description here just gives you some informal English description, and the meaning over here. All right, let me say it again. The description here, I'm going to give you the formal terms about how usually computer scientists actually call them. And also meaning here will just give you some informal meaning. But for the precise meaning, we're going to use the so-called truth table to define them. All right. Okay, first of all, this is what you write, exclamation mark. So this is something I show you actually in the previous part of the lecture without introducing it, but that's the exclamation mark. And the formal name for that would be logical negation. And sometimes people simply say negation, but I would prefer logical, right? We're really talking about using this operator to produce a Boolean type expression value. And then the meaning is simply not, right? Easy. But I'm going to define that precisely still. The second one, ampersand without any space. So this is a binary operator, and the formal name for that would be logical conjunction, or you can simply say conjunction, all right? And then the meaning will be just and. Something and something. Think about in real life, what's really the meaning for X and Y? Or I want to say, I want to play basketball and I want to play football, right? For example, what does that really mean, right? And then we got another one, vertical bar, again, without any space in between. And then there'll be logical disjunction over here, right? That's the formal name, disjunction. Well, so typically, I might just say negation, conjunction, disjunction, right? Or you can say not, and, or. I would say these the third column over here are a little bit more like a layman's term. But here, this the description over here, that's more about the terms that computer scientists communicate with each other. So I would say get used to both. All right, so now let's define each one of them. And then we're going to give you examples to really, and then I'm going to trace them through. So at this point here, I'm not going to use flowchart anymore. I would say in the previous video, we already showed you all the different cases for if statement execution using flowchart on the code directly on the paper and also on Eclipse. For now, I'm just going to leave out flowchart in our discussion, right? But I'm going to still do tracing on the code directly on my iPad and also on the Eclipse. I think these two things are very crucial for you to understand the code behavior. All right, I'm going to use my iPad from now on. And then, first of all, let me define exactly what each of these logical operators really mean. And then I will give you example for each one of them. All right, so now let's start with the simple one. So we got negation over here. Negation, okay. And you might have seen this symbol already, right? So this symbol over here is written like this. Okay, so this is the logical symbol mathematicians write. And then informally, it's simply just not, right? So let's go through the syntax for each one of them very quickly again. And also we got conjunction. Okay, for conjunction, and the symbol is like this if you're taking also for mathematician. So that will be something like that. All right, and then that one is for for and, informally. And then we got another one, disjunction over here, and then it will be written like this. Okay, like that, like a V in some way. This is like an upside down V. And then we have informal meaning will just be or. All right, so that's about the syntax for each one of them. And now, in order to define for the meaning for each one of the operators, remember each, for example, let's say this. Think about for conjunction. Let me just tell you what the truth table is, in case you don't know. You may have seen this before, but maybe you have not. For example, if I have an operator over here, let's say it's a logical operator. And let's say the logical operator is binary. So I'm talking about either conjunction or disjunction over here, right? So you got left operand over here. You got right operand over here, right? The left and also the right operand. So now we want to define for all the possible scenarios how what the value it should be evaluated into. So we want to say for this particular logical operator, which can be either conjunction or disjunction. So now we want to talk about all the possible combinations of left and right and what the corresponding value should be evaluated into, right? So now we want to see about combinations, right? A little bit about combinatorics in mathematics, but very easy. You want to think about how many possible values are there for the left operand. Remember, for the logical operator, both of its operands, as I discussed, should be simply Boolean. So this part here can either be true or false. Similarly, this part over here can also be either true or false. So now how many combinations do we have, right? So it's going to be false, 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 true, true, false, and also true, true. 4 possibilities. All right. So hopefully you are comfortable with the justification for the layout for the truth table, right? We got 4 possibilities. So that's exactly false, 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 true, true, false, and true, true. So this will be the left operand, this will be the right operand, and this is the left operand, the right operand. So we talk about all the 4 possible combinations for the left and right operands, right? That's important to note. And then we'll see. So now, if it's for this particular combination, what should be the corresponding conjunction be, right? You can see, given that P and Q are simply just false, and what should be P and Q? And similarly, given that P and Q are both false, and what should be P or Q? All right, and then we want to talk about all the possibilities. I'm gonna give you intuition in just a moment, so it's very easy. You don't need to memorize really. All right, so now similarly, so you can see the truth table size for a unary operator negation is actually smaller. It doesn't really surprise, because so here there's only a single operand. What can be its value? Either false or true. All right. So now let's talk about it. In order for I'm just going to do the following. You can see the precise definition in the slides, but now I want to be a little bit visual over here. I'm going to use the pink, like a red, for false. I'm going to use the green for true. So you can see corresponding to the color. In the case of negation, it's simply just going to flip the result. Very easy. So now if I got false over here, of course it's going to flip the result to be true. And then if I got true over here, it's going to flip the result into false. All right, it makes sense. So for negation, it's very straightforward. I don't need to bother you too much. We're going to see examples to see how to manipulate this operation in just a moment. So now what about conjunction and disjunction? I would say for conjunction over here, it's really and, which means conjunction result. So this is how I remember it, or intuitively. The conjunction between P and Q will only be true if both operands are simply just true. Meaning that if both operands are simply true, that means the result for the conjunction will just be true. In other cases where either or both of the operands are simply false, you can see in this case, one operand is false. In this case, one operand is false. In this case, both operands are false. In those cases, it's going to violate the definition for and. So that means they are just going to be false. Over here, false and false. Let me reset again. But you can see very easy. But I don't want you to really memorize the truth table. That's not the way to go scientifically. So you just want to know, in conjunction, under what circumstances are you going to get true for conjunction? So that means both operands must be true. If either or both of the operands are simply false, in that case, it would be false. Right? That's for conjunction, and. All right, and then let's do the final operator. So now for disjunction, I would say that's kind of symmetric, similar to conjunction. So now you can think about in real life, when I say disjunction, I really meant either this holds or this holds will be okay. Either one of them, as long as it's not both, that actually doesn't hold, right? Exactly. So now I would say the following. This is how I understand it. So think about it's going to happen in this way. So disjunction between two operands is only going to be false if both operands are actually false. Because if both are false, or like both do not hold, so that means it's going to violate the definition for or, right? Okay, for example, if I say I want to either play basketball or I want to play heavy metal music. But if it turns out I play soccer or football, in that case it should be false, right? Because I'm doing neither basketball nor heavy metal music. Hopefully you see that, right? So now that's the only case where the disjunction can be false. If either one of the operands is actually true. So you can see this operand is actually true, this operand is actually true, and both operands are true. If either or both of them are true, in that case, the result will just be true. Using my example over here, if I play heavy metal music, but I didn't play basketball, would that be okay? Yes, that'll be okay, because I still play heavy metal music. And if I play both heavy metal music and also play basketball, that will also be true, right? So again, let me recap very quickly. You want to think about these two operators in the symmetric way. For conjunction, it will only be true if both operands are true. it will be false if either or both of the operands are actually false. All right. And now for disjunction, it will only be false if both operands are false. And then if either of the operands are actually true, the result will just be true. All right, so that's the definition. I would say pause the video and really make sure you really understand intuitively how to evaluate these operators. I would say in the very first week, or in the very first few days, or even in the very first few hours, when you actually look at the code involving logical operations, it would be okay if you simply just look up the table over here to see. Right? However, I would say later, or for example, in the test or in the exam, if you still have to rely on this table over here to tell you the definition, I would say that's not a good sign. All right, so make sure you understand intuitively. All right, so now we're going to see the example for each one of them.